So this is the basic block diagram of the cyber attack impact. You can see this, the starting point is a cyber attacker. After the cyber attacker launched the cyber attack or intruding into the systems, so the main path is communication infrastructure. So after once the cyber attack entered the communication infrastructure, they will create the malware. So this malware is completely different from the virus. So malware means it's nothing but a small program which will be intruded into your system and start executing in the later time. So it is not similar like a virus. Virus means it can be spread from one system to another system, but malware means particularly designed for only one system. That is very small program and takes some time to be effective into your system. So the next stage is vulnerability exploitation. So the vulnerability is nothing but the weakness in your system, and it will become a unauthorized access to the SCADA and DCS control systems. Then it will be changes the control system data, and finally it will enter into the sensor, actuator, SCADA, DCS, and the PMU, which will be threatens the stability and it creates a loss of load. So this is the impact on cyber physical power system. So finally, what is the objective of the cyber attacker on impact and CPSs? They want to increase the power flow, or they want to decrease the power flow in the transmission system. They want to lose the stability of the system, and they want to increase the loss of load connected to the physical power system. So this is the main objective of the cyber attacker for creating the impact on a cyber physical power system. So the illustration of the block diagram which is shown in, you can see this, the New England 39 bus system taken as a case study, and then the measurements will be taken by the communication network. So through this wireless communication network, it will be moved to the control center. Now the operator in the control center will assess the data, and if there is any attack occurred in this data, using this attack detection algorithm, they will detect uh, any type of that is a misleading things or actions are happening in the system. So if it is happened means they immediately give the control instruction or control action to the new blood test systems. So here the main point of attacking is the attacker take the advantage of this communication network. So since it is a wired or wireless, so any type of system of communication infrastructure, the attacker can be easily to attack the communication infrastructure, which will affect the whole system operation. So the next thing is modeling the different types of a cyber attack. So the first type is called as a single cyber attack. So the subclassification of the single cyber attack is a ramp type attack. So as you know that the ramp type attack is, it is a linearly increasing one. So initially it will be very slow. After entering into the cyber physical power system, it will be gradually increases and amplifies this intensity of the operation, that is called as a ramp attack. So initially, it will be very slow. First, it will imitate a normal pattern. After slowly development, it is very challenging for detection in the system or recognizing it. So the second type of attack is called as a step attack. So it is also gradually penetrate into the system or your power system network. So after it, sometimes it will improve the vulnerability of the system, and then the one before it leads to the a severe attack will be happen in the physical power systems. So this type of attack also have a less chance of being discovered in this physical power systems. So the mathematical model, the equation for that, both ramp attack, you can see this first up to from zero, the time 0 to 7. So the ramp attack which have a 0 magnitude, and from the time period after 8, so the magnitude of attack will be 0.03. So this type of attack depends on the characteristics of that attack, which will be threaten our physical power system, or it will affect the behavior of the physical power system. So the the third type of attack is called as a impulse type of attack. So it's nothing but like a pulse or a sudden spike. So that is called as a impulse type attack. So there will be a abrupt spike in the malicious activity in the physical power system. So the impulse attack also very difficult. Sometimes it overlaps with the transients of the physical power system. So that's what very difficult to differentiate whether it is a impulse type attack or a transient effect in the physical power system. And then the fourth one is a very familiar one, false data injection attack. So it will completely very dangerous compared to the previous one, because it will changes the control command to the physical power systems. So if there is any change in the command to the physical power system, it leads to the blackout or cascading failure in the physical power systems. So these four types of attacks is called as a different behavior. We can see that whether single type of attack, how it will impact the system, and if it is coordinated, how will attack, as well as multiple type of attacks, how it will be affect the performance of the physical power system. So the results I have shown below, you can see this. This is a single type of a cyber attack. So the black one, which will be represented as the a normal condition, and then FDIA, false data injection attack, single attack. That means the step attack. SEA means it is a step attack, ramp attack, as well as the impulse attack. So with this single type of attack, the individual attack is happening. Can see this all three types of attack. The step attack, ramp attack, impulse attack having a severe impact on the STATCOM voltage. And then the second one, the coordinated cyber physical attack, as well as the multiple cyber attack, also severely impacting the performance of the STATCOM voltage. So the same effect, the single cyber attack, the same effect on a, you can see this the zoomed view of this STATCOM voltage response. So it is creating the increase of the voltage scenario. And then the figure number 7 represents the voltage measured at the bus 6 of New England systems. So in this single cyber attack scenario, you can see this compared to the normal behavior, the false data injection attack is completely increasing the voltage at the bus 6 in this New England 39 bus system. So from this graph, what we are inferring means that the single type of attack, one type of attack occurring at one time also, it is severely vulnerable to the physical power system. So the next thing is active power of generator 32. So the power from the generator 32 also impacted by this single type of cyber attack. You can see this both the ramp attack as well as the impulse attack. Compared to the normal state conditions, the attack is creating the huge increase of the voltage in the active power of generator 32. So the figure 9 and 10 shows the active power of generator 32, and then the zoom review of the active power of generator 32. We can see this, the comparison between a normal fault condition. So first one is a normal condition, that is the normal power system condition, and then the last one is faulted condition. So compared to this physical one, the cyber fault, multiple cyber attack ones, multiple cyber attack two, and a coordinated cyber attack one and coordinated cyber attack two. So this compared to the CCPA and the multiple cyber attacks, so this multiple cyber attack creating a huge impact on the physical power systems, which is very, very dangerous compared to the coordinated cyber attack. So the next one is the Thailand power transfer. So we know that there are the New England bus system consists of 5 regions. So the uh, uh, regions, it is divided as 5 regions. So the one region to one area, that is 5 areas, one area to another area, which is connected through the Thailand power. So the Thailand power also decides the stability of the system. So you can see this with a normal condition, the power flow is 295 megawatt. And with the impact of this false data injection attack, as well as the single step attack, it is showing that a peak rise of nearby 310 megawatt is rising from 295 megawatt. And then the second case, figure 12 also, it shows the impact of this coordinated cyber attack and multiple cyber attack. So this also, from this diagram, what we are inferring, this multiple cyber attack is very, very severe compared to this coordinated cyber attack. So the rotor speed deviation. So the initially it shows the peak rise of this rotor speed deviation of 39th generator with a single cyber attack, and also the speed deviation of 39th generator with a coordinated cyber physical attack and multiple cyber attack. So for all the physical parameters are completely affected initially for that 200 to 300 seconds are affected by this the impact of cyber attack. And you can see the rotor speed difference between the generator 36 and 38 with a single cyber attack. So the each type of the cyber attack creating the some disturbances in the stability of the physical power system. And then figure 16 shows the speed difference between 36 and 38, which both are showing the wide area of stability of the this New England 39 bus system. So again, this multiple cyber attack is very dangerous compared to the coordinated cyber attack. So what is the conclusion means it is necessary to analyze the impact of cyber attack in the electrical power grid. So not only the physical fault, so line to line fault, three phase fault. In addition to this, we need to assess the performance of cyber attack on electrical power grid. So we have seen that the simulation scenario for different types of attacks: single cyber attack, multiple cyber attack, and a coordinated cyber attack. So among these three type of attack, these multiple cyber attacks are more vulnerable than dangerous compared to the coordinated attack in cyber physical power systems. So comparing this four types of individual cyber attack, this false data injection attack is very dangerous and vulnerable compared to the step ramp and impulse type attacks. So we need to create a strong cyber defense or cyber security algorithm or any emergency plan like islanding or mitigating any other plans. Mitigation plans should be there for to face this cyber attack. And last one, there is no doubt that multiple cyber attacks is always creating a big impact to this power system grid. So overall, this work is fully based on assessing the impact of the cyber attack on physical power system. So we have submitted this work to computers and security, and the first revision is completed. The first major revision is over. Again, the first major revision is under review to the reviewers. So the impact factor is a 4.8, which is a Q1 journal, and received the positive comments from the appreciation from the editor as well as the reviewer. And these are the references for this impact of cyber attack on physical power system. So thanks for your attention. Thank you. Yeah, any doubts you can ask me. Is any doubt?
Participants, if you have any queries, you can ask the session speaker. Just 2 minutes. I'll post the attendance link for this session. Just 2 minutes. Yeah.
So if there is no questions, we can mount the session. Thank you, Raja Vikram. Thank you.
Thank you, sir.
For
Thank you.
your
Thank you, sir.
presentation. Thank you.
Thank you. Thank you, sir.
Thank you. Dear participants, next session will be at 5 p.m.